Multiple transformations of square root function. Explain the transformations of f of x equals to minus 2 square root of 6 minus 3x. Sketch the function and write its domain and range. Well, this is a very interesting question, and once you understand transformations regarding this function, you can probably do transformation for most of the functions, right? So let's try to see step by step how to write transformation and how to sketch the given function. Okay. So the function given to us is f of x equals to minus of 2 square root of 6 minus 3x. Now I'll always suggest you to rearrange these numbers inside the bracket. You should factor so that the coefficient of x is always 1, and then you start writing the transformations. Otherwise you can make mistake. If you look at it like this, at times you can say that's moving left or right by 6 units, right? Which is definitely a wrong answer, and you will soon discover. So we can write this function as minus 2, and inside let me factor out minus 3 and write x term first, right? So we factored minus 3. 6 divided by minus 3 will give me minus 2, correct? Now I think you can write down the transformations, correct? It's evident that the translation is not by 6 units, but it is 2 units, correct? Now let me put transformations one by one. Now the first transformation, so let me just list. So we can write from left to right also. That's one way of doing it. And the other way to do or write transformation is you can go from inside out, right? But always when you list your transformations, it is important that all multiplications should be written first. Now, as I've seen most of the examples, if we move from left to right, we take care of multiplication, order of operation, and everything. So it's best to start from left and then end to the rightmost thing. So from left we say minus, that is reflection, right? It is reflection on what? It's a vertical reflection. So when it is outside the square root function, it is reflection on x-axis, okay? That is how it is. And 2 is a vertical stretch. By what factor? By factor of 2, correct? So by factor of 2. The word factor is important since it's getting multiplied. So don't write vertical stretch of 2 or something like that. It could be translation, it could be confusion. Okay, so it should be vertical stretch by a factor of, so you have to multiply by, right? Then as you move inside the bracket, everything inside the bracket refers to horizontal. So this is horizontal reflection, right? So it's a reflection on y-axis, okay? So horizontally the graph will move, and that is reflection y-axis, and this is the k factor, 3. So it is horizontal what? Tell me. Stretch or compression? If the number is bigger, we do just reverse. Compression, right? By factor of how much? 1/3, correct? So it gets compressed. Now the last one here is minus 2. Minus 2 means it moves 2 units to the right. So translate 2 units. Right, okay. Or we could write horizontal translation of 2 units to right. So we have written our transformations. Now let us sketch it. Can you comment on the domain range of this at the moment? Well, we can. For the domain and range, I would like to say it is better to sketch it first and then write. But looking into domain at this stage is not a bad idea at all. So when you look at domain, what you should do is, let's look into domain now. So when we are considering domain, then we should know square root function inside should always be greater than equal to 0, right? Otherwise you get imaginary number. So we can start with the original function itself, and what we should do is we should calculate what is the value or for what value of x will inside square root function remains non-negative. That is what it is, right? So what we are trying to check here is trying to solve this inequality, that is 6 minus 3x should be greater than or equal to 0. So this is the inequality we are trying to solve always, right? So we can say we can bring minus 3x this side, or we could also bring 6 the other side. So I'll bring 6 this time to show you another very important aspect. So that is, we have minus 3x is greater than or equals to minus 6. And now we'll divide by minus 3. So when you divide by minus 3, you get x here, and minus 6 divided by minus 3 gives you 2. But at this time, you have to interchange the sign also. So the sign becomes less than or equal to. So the domain here is that x belongs to real numbers and x is less than or equal to 2, right? So that is the domain for the function, right? So I hope that domain part is also clear. Now let's try to sketch this function, right? So I'll squeeze in a small sketch here. Okay, so we'll start with the original square root function, right? So we are doing transformations with respect to what? So our original function is square root x, is it okay? So we'll say, well, this is my square root function, okay? So this is square root function. Let's do one by one. That is reflection on x-axis. So what happens when we reflect it on x-axis? Let me show it on green color, right? So this is reflection on x-axis. This is that minus thing, right? So we are not talking about this minus, so it just gets reflected on x-axis. This is your x-axis, right? So it just gets reflected here and it becomes like this. Do you see that? So that is the reflection on x-axis. Now the next part is we will get into sketching the function with vertical stretch. So let me show this red color vertical stretch. That means every point will get stretched by a factor of 2. So earlier it is 1, it becomes 2. So everything, let's say, so they just stretched like this. So we get a function like this, right? So that is, so let me write this as minus 2 square root of x. That is the function. And previous to this, we have sketched minus square root of x, correct? And previous to this, we did square root of x, the original parent function, right? And now let's get into the square root sign, and we are left with minus. And this minus is kind of a reflection on the left side, right? So let me pull out a few more pens here. So different colors. So now we are using a different lighter green, which you may not clearly see, but it's a reflection on y-axis. So we'll reflect this and we reflect it like this, correct? So this one, so let me write in black since this is not very clearly visible, right? So I'll write this as minus 2 square root of minus x, okay? And let me differentiate that side with this color, okay? So that is, we are done reflection on y-axis. Now let's do compression. So we'll compress it, this time a stronger color, by 1/3. So we have to do horizontally compressed by 1/3. That means these points, they move. Let's say this is half and like 1/3, right? So they all get inside. You see, let's say we consider this point, so it just gets inside. 1/3 means they will just be pushed like this. So what we see here will be a function like this, correct? So it looks vertically stretched, but actually we are doing horizontal compression by 1/3. And at this stage, this particular function which we have drawn here is equivalent to minus square root of 3x. Do you see that? That is the function. And now, last and final, we will do the translation of 2 units to the right, correct? So let me do 2 units to the right in this color, okay? So we'll do pink color this time. Okay. So we'll translate the whole graph 2 units to the right. So let's say this is our 2, and so we do a translation of 2 units to the right. So that becomes our function f of x, correct? Now this f of x is actually minus 2 square root of, so I'll write in this form, which is minus 3 x minus 2. Correct? So that is how you do step-by-step transformation of square root function. If we add some vertical translations, it can move up and down, which we didn't take in this particular case. Now we got the function, right? So that is our final function. That is how it should be. What is the range of this function? Now let's write down the range. As you can see, this minus flips the range. Original range is y greater than or equal to 0, but now it becomes less than or equal to 0 because of this negative sign, correct? So we say y belongs to real numbers, so that y is less than or equal to 0, right? So that becomes the range. I hope with this example you have fairly good idea about how the functions should be transformed and how we should look into their domain and range. So go through this video once again, try to understand each and every part. Important things which we consider here are like this. First, whenever you're given a function, rearrange, right? So we rearrange, right? That is a very critical step, and we say rearrange. If you don't rearrange, you can get a couple of wrong answers, especially horizontal translation. I've seen that mistake in so many papers. Okay, avoid that. If you get that wrong, you get a lot of mistakes here, right? Now, then when you write your transformation, you have to write in a way so that your order of operation is maintained, okay? So when you write this order of operation, let me write like this, order of operation. Okay, so you have to maintain the order of operation. Multiplications first and then addition, subtraction. That means stretches, reflections first and then translations. So that has to be at the end, okay? You could change that order, doesn't matter, but you can't mix translation with any one of them. So maintain that. And then follow your steps of transformation to sketch the graph. Once you sketch the graph, you are in a position to write domain and range, right? For square root function, I recommend that when you get a function, you should first do domain range, so that is a check on rest of the things. If you've done a mistake here, this will help you to figure it out, correct? So if you have solved that x is less than or equals to 2, then you know that this needs to be factored. Do you see that? It is related. This 2 is related, so this needs to be factored. So all these things, if placed in a proper sequence, will result in excellent solution of a problem, right? I hope you benefit a lot from it. Share with your friends and do your best. Thank you.